we want to begin to look at monomials and polynomials, and we're going to be doing different things with both. But we want to start with looking at a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. Notice we didn't say anything about a sum or a difference. A number, a variable, or a product of a number and one or more variables. An expression involving division of variables is not a monomial. Okay, so if you have in the denominator, if you have a variable, it is not a monomial. Monomials that are real numbers are called constants. 6 is a constant. -2 is a constant. So if we look at these expressions, we want to determine whether they are a monomial or not. And if we look at number 1, this is not a monomial because it involves addition and not multiplication. That's the reason it's not a monomial. It involves addition and not multiplication. Number 2 is a product of a constant and several variables, so it is a monomial. Number 3 is the product of variable expressions and a constant. We could even write this as 1/3 xy squared. So yes, this is a monomial because it is a product of a constant and, variables. Number 4 is not a monomial because we are dividing by a variable. So that means that it is not a monomial, dividing by a variable. So that's how you can tell if you have a monomial expression or not. Monomial, mono means one. Now here I have 2 to the 5th. 2 is called the base. And in this expression, 5 is the exponent. So we're going to be looking at some numbers that have a base and an exponent and taking it a little bit farther than you've seen before. If I have the expression 2 squared times 2 cubed, that means I have 2 as a factor 2 times, and then I have 2 as a factor 3 times. So we have a base of 2, 1, 2, 3, 4, 5 times, so our new exponent is 5. If we look here, we have x as a factor 5 times. And then we have x as a factor 1 more time. So x is a factor a total of 1, 2, 3, 4, 5, 6 times. Notice if I had added 2 plus 3, I get 5. If I added 5 plus 1, I get 6. So that helps us to see a rule or a pattern that we could follow. To find the product, multiplication, the product of powers, to multiply 2 powers that have the same base, we can add the exponents. Just like we did in the previous problem. In other words, if we have a number a and integers m and n, that just means no fractions, then a to the m times a to the n could be rewritten as a to the m plus n. So a to the 4th times a to the 12 could be written as a to the 4 plus 12. or a to the 16th. So if we're going to simplify some expressions, I'm going to multiply the real parts together, 3 times 7, and then we'll multiply the y expressions together. So 3 times 7 is 21, and our rule says that if we have the same base, we can add the exponents. So 21y to the 9th. Same thing over here. I can multiply the constants together. -4 times -6. We're multiplying. Then we would have our r times r to the 5th, and if there is no number there, we know that a 1 is understood. Then we have s squared times s squared, and then t cubed times t cubed. So if we simplify, we would have 24, r to the 1 plus 5, s to the 2 plus 2, and t to the 3 plus 3, which is, of course, t to the 6th, and we are finished. On the third one, if there is no constant, it's understood that there's a 1 there. So we'd have 1 times -12, and then r to the 4th times r to the 7th. So -12, r to the 4 plus 7, which is 11. On the fourth one, we multiply our constants together. 6 times 5, c to the 1st times c to the 5th. If you want to, you can write that first so you don't forget that it's there. And d to the 5th times d squared. So 30, c to the 1 plus 5, which is 6, and d to the 5 plus 2, which is 7. Now this product is a little bit different. Notice we have a power raised to a power. If I were going to rewrite this, this means that 4 squared is a factor 5 times. 4 squared times 4 squared times 4 squared times 4 squared times 4 squared. And we know from our previous rule that we would have 4 to the 2 plus 2 plus 2 plus 2 plus 2, which is 4 to the 2, 4, 6, 8, 10. 4 to the 10th power. The second problem tells us that we have z to the 8th as a factor 3 times. Z to the 8th times z to the 8th times z to the 8th. So we would have z to the 8 plus 8 plus 8, which is z to the 24th. Notice this is a little bit different. I got 4 to the 10th on the first one. And notice if I multiplied these two powers together, I would get a 10. I got z to the 24th on the second one. Notice if I multiplied 3 times 8, I would get 24. So to find the power of a power, we multiply the exponents. Now you need to be sure you're taking notes because you can use your notes on a test. We multiply the exponents. So a to the m times n, a to the m raised to the n, becomes a to the m times n. And k to the 5th times 9 becomes k to the 5 times 9, or k to the 45th power. Notice we multiply those exponents together. So let's simplify this first problem. I'm going to work from the inside out. So I would have 2 squared squared. Notice I can multiply these two together, which would give me 2 to the 4th raised to the 4th power, which becomes 2 to the 16th. You also could work it the other way. We could say, multiply these two, 2 squared to the 8th and 8 times 2 is 16. So either way, you get the same answer. If we start from the inside, I'm going to have 3 squared squared, so we multiply these two, 3 to the 4th squared, and now we multiply these two, and we get 3 to the 8th. Now in the previous examples, we just had a single base, but now I have a base that's a product, and we're going to find the power of a product. This means that we have xy as a factor 4 times, xy times xy times xy times xy. I'm just rewriting it. Let's see if we can discover a rule that we can use to solve this one. I can get x, multiply the x's together. I have x as a factor 4 times and y as a factor 4 times. And so we have x to the 1 plus 1 plus 1 plus 1, and y to the 1 plus 1 to the 1 plus 1. So we have x to the 4th, y to the 4th. If we look at the next one, this means that 6ab is a factor 3 times. Okay, 6ab times 6ab times 6ab. So I multiply the 6's all together. 6 times 6 times 6. A times A times A. And B times B times B. So we'd have 6 to the 3rd power, A to the 3rd power, and B to the 3rd power. And you can use a calculator to determine that 6 to the 3rd power is 216, A cubed, B cubed. Now notice what happened. We multiplied both factors, their exponents, together. 4 times 1 is 4, 4 times 1 is 4. Each factor, we multiply its exponent by the outside power. 3 times 1 is 3, so here's our 3. A to the 1st power raised to the 3rd power is A cubed, and B to the 1st power raised to the 3rd power is B cubed. So if we want to come up with a simple rule to find the power of a product, we find the power of each factor. Find the power of each factor, and then multiply. So if I have AB to the M, that becomes A to the M, B to the M. Remember, if there is no exponent, 1 is understood to be there. If I have negative 2xy and it's all raised to the 3rd power, that means we have negative 2 cubed times x cubed times y cubed. Negative 2 times negative 2 is 4 times negative 2 is negative 8. X cubed, y cubed. Now I have a square, and if we want to think about the area of a square, all the sides are the same, so the area of a square is side squared. If one side is 4AB, and I square that, I'm going to have 4 squared times A squared times B squared, or 16A squared, B squared. So we find the power of each factor, and then we multiply. Now when we simplify these monomials, each base can appear exactly once. It's not simplified if you have x squared times x cubed in your final answer. Each base appears exactly once. There are no powers of powers. And all fractions are in simplest form. You would not have 2/8, you have to reduce it to 1/4. So let's look at a couple. These are a little bit more complicated, but it's not, I believe you can do this. For the first factor, we would have 3 squared times x squared times y to the 8th. And here, we could simplify. I could multiply these two together if I want to first. Negative 2y to the 6th. This becomes 9x squared y to the 8th. And negative 2 to the 6th y to the 6th. Negative 2 to the 6th. If I multiply a negative 6 times, I'm going to have a positive number, and this becomes 64. You can use a calculator. Y to the 6th. So we're going to have 9 times 64, x squared, y to the 8 plus 6 is 14, and 9 times 64 is 576, x squared, y to the 14th. You may use a calculator. So let's look at this last problem. Work through it. We do things in order. So I'm going to have 1/2 cubed times a to the 6th, we multiply b to the 6th, we multiply the exponents because it's raised to a power. Here I could go ahead and multiply and have negative 4b to the 4th. So both of those factors in that product are going to be raised to the 4th power. 1/2 cubed, 1/2 times 1/2 times 1/2. We multiply across the top and multiply across the bottom. So we have 1/8, a to the 6th, b to the 6th for the first term. Here I'm going to have negative 4 to the 4th, b to the 4th, and negative 4 to the 4th. You can use your calculator. You're going to have 16. If I think about it, I have negative 4 times negative 4 times negative 4 times negative 4. So this is 16 times 16. So we have 1/8, a to the 6th, b to the 6th, times 16 squared, b to the 4th. Now, if you didn't have a calculator, you could think about your constant terms as 1/8 times 16 times 16. 8 goes into 16 2 times, so we're left with 2 times 16, which is 32. A to the 6th. I don't have an a in the second term, so it's just a to the 6th, b to the 6th plus 4, or b to the 10th. And that's how we can work with these monomial expressions.